So welcome back my dear students again. This is the lecture number 12, and in this lecture we are going to discuss about the second law of thermodynamics. Okay, so what is the topic today? We are going to discuss second law of thermodynamics. If first law is available, then why the second law is required, children? It's required because what is the first law? If you remember, what is the first law? First law was based upon the conservation of energy. Conservation of energy. That means energy never will be lost. So from here you can say delta E is equal to 0. Change in energy will be 0. Energy can be converted into one form to another form. Delta E, or you can say delta E for universe, because we are talking about the whole universe. Energy will be exchanged only one form to another form. Like if you are rubbing your hand, then energy generated. Your heart becomes warm. So there are some limitations of first law. What are the limitations, children? Limitations means according to the first law, it is only saying that energy never will be lost. It can change from one form to another form. But like heat, suppose what is the concept of heat flow? Heat is flowing from higher temperature to lower temperature generally. But this explanation, this directional explanation is not given by the first law. He is only saying energy will be conserved. That's it. So in the limitations of first law, the first point is heat can flow from hot body to cold body. Hot body to cold body, but not from cold body to hot body. That is the general concept. But it can be done in the case of refrigerator, children. What happened? From cold body to hot body, transfer of heat is there. Your freeze is freezing ice and heat is coming out from the freeze. Yes or no? Yes. In that case, it is not flowing from hot body to cold body. In the case of fridge, it is flowing from cold body to hot body. So the concept is flow of heat. Flow of heat direction is not explained by first law of thermodynamics. Second, the very important feasibility of a process, or you can say spontaneity. Feasibility or spontaneity of the process cannot explain by the first law. Which process is spontaneous, which process is non-spontaneous? Spontaneous means process which happened by own. Feasible process which happened by own. Same thing. Which happened by own. Natural process are spontaneous, like water is coming down from the hills. But you can rise water from bottom to top also by using that DC motor or submersible. It is also possible. So how can we say which process is feasible, which process is non-feasible or spontaneous, like that? So these are the things which is not clear. Number 3, the natural spontaneous process. The spelling is wrong. Natural. The natural spontaneous process are what? Irreversible. That means water is coming. What is the nature of water? It flow from high to low. That is natural process, and it is irreversible. That means water cannot flow from low to high place. But when you will apply the DC motor, it will be possible. Number 4, according to the first law, can you form 100% efficient engine? 100% efficient engine. Efficient engine formation is not possible. But according to first law, it is saying yes, it is possible. Like suppose you are going with your scooter in the market and your petrol finish. That time you can take heat from the atmosphere and your scooter again start running. Is it possible? No. Is it 100%? That is not possible. But first law is saying it is possible. So these are the things which are not explained by this first law. Then second law will tell about what? Second law tell? Second law explain about the process is spontaneous or non-spontaneous. That means it is feasible or not feasible. That will be explained by the second law. So now we will discuss about the process, which one is feasible, which one is you can say spontaneous, and which one is non-spontaneous. So be with me. We'll discuss each and everything in this case. Spontaneous process, okay. Spontaneous process. What's happening? Non-spontaneous process. So here we are going to classify spontaneous process and non-spontaneous process. Okay. So my eraser is not working this time, but what we can do for this? What happened actually? So spontaneous process and non-spontaneous process, we are going to discuss about the difference, children. So spontaneous process are those which happens by own, or you can say here, wait 1 minute, this is not required. A spontaneous process any process which has a tendency to occur, or you can say urge, number one, by itself, or you can say on its own, process which happens by own, like flow of water from top to bottom, or you can, second is by proper initiation. What is proper initiation, children? Coal and oxygen both are available, but they are not start burning. For that you have to initiate the process, you have to give them fire, then coal start burning in the presence of oxygen. That is called proper initiation. Or you can, third point is under given condition. So these processes will be spontaneous. One by one we will discuss. So first, by own, process which happens by own. Number one, like sugar or salt dissolution in water. This is a spontaneous process. If you are putting sugar in one glass water or that salt, it will dissociate into the water. Second, evaporation of lake. Lake or pond water evaporated by own, that is called evaporation. So evaporation of lake is a spontaneous process. Flow of heat, higher temperature to lower temperature. Many example I can give you. Diffusion of gas from higher pressure to lower pressure. Next, you can say melting of ice. Which kind of process? This is also a spontaneous process, without any external force it is happening. So these kind of process are spontaneous process by itself. Second is what, children? By proper initiation. So H2 plus O2 both are gas and they are forming 2H2O liquid. By the hydrogen and oxygen, water is formed. In the atmosphere, oxygen and hydrogen both present, but water is not forming. For that we have to initiate. How to initiate? Electric spark. If electric spark you will provide, then this process will happen. So that is called proper initiation. Like carbon solid plus O2, they provide carbon dioxide. For that also we have to ignite the process, then it is possible. Or you can say CaCO3 break down into CaO and CO2. So that is also when you provide heat, given set of condition. Initial heat is required for this process. So these are the things for a spontaneous process. Okay. Then come to the non-spontaneous process. Non-spontaneous process. What is non-spontaneous process, guys? A process which has no tendency to urge or to occur, number one, on its own, they not happened by own, or even proper initiation. After the proper initiation also these processes not happened. And the very important note here, nobody will tell about this: if continuous energy, which energy? External, is supplied, so that is the important part here. If continuous energy is supplied, then this process can be happen. Water cannot flow from lower height to upper height, but when you are applying that Tullu motor or DC motor, then water flow from upper height to higher height. Or refrigerator example I have given, lower energy to higher energy. Inside the refrigerator, ice is there and it is releasing heat. When ice will be converted? Water to ice, when it release. So these are the examples of this process. Okay, spontaneous. Got it? Example, if you are talking, then I can give many example here also, like heat flow from body at lower temperature to higher temperature. It is possible? Not. So it is non-spontaneous process. Similarly, second example of water flow of water. I'm not writing. So this is about the spontaneous process, non-spontaneous process. But the thing is, how we will decide which process is spontaneous, which process is non-spontaneous, which is happening by proper initiation or which is not happening by proper initiation? In that case, second law will decide the process is spontaneous or not spontaneous. Criteria to decide spontaneous or spontaneity. Criteria to decide spontaneous or spontaneity, for that three variables are there. What are the three variables? Enthalpy, that is called delta H, entropy delta S, enthalpy change, entropy change, enthalpy change, and third is Gibbs free energy. So these are the 3 steps from which we will determine which process is spontaneous or non-spontaneous. So this is the criteria to decide the process is spontaneous or non-spontaneous. So that we will discuss in the next lecture, all these terms. So this is all about video number 11. Thank you, children.